In this section, we're talking about the families of deep neural networks and their applications. Dense networks are the backbone of these live lessons. They're relatively simple to describe, and in fact, we already built one at the end of lesson 1. So although we built it shallow with only one hidden layer, this was a dense network where we had all of the inputs feeding into all of the neurons in the hidden layer, which themselves then fed into all of the neurons in the output layer. So that kind of architecture is fully connected or dense. You can't imagine it denser than that. These kinds of dense networks are broadly useful for non-linearly combining information. They can be used on their own to make categorical predictions or to estimate outcomes given some input data. Dense networks are often included at the top of other types of neural networks to improve their accuracy. So, for example, you could have a convolutional network, which we're talking about next, for machine vision with dense layers on top, and that allows us to recombine the information learned by the convolutional layers down below. The dense layers of networks will be very involved in every network that we built in these live lessons, so get used to them. Convolutional networks, or ConvNets for short, are best known for their use in machine vision applications. For example, they're used in the object recognition of self-driving cars. They're used in face recognition on Facebook. They're used often to classify images like the MNIST digits that we did in lesson 1. In addition, beyond machine vision, convolutional networks have turned out to be useful in analyzing any kind of data with spatial patterns. So even natural language can have a spatial pattern to it that can be picked up by a convolutional network. ConvNets are a big part of what we cover in these live lessons. In lesson 3, we'll dive into the theory of convolutional layers, and after that, we'll leverage convolutional networks quite a few times to improve our accuracy on machine vision tasks with both MNIST digits and other data. Recurrent neural networks, or RNNs, are typically used when we're working with data that come in a sequence. Natural language applications are a particularly common use of RNNs, and they are applied to time series data like financial or econometric data as well. In the deep learning literature, you'll often come across a specialized type of RNN called LSTM, which stands for Long Short-Term Memory Network. While both RNNs and LSTMs are super cool, they're beyond the scope of these live lessons, but we'll be sure to cover them in a future one. Reinforcement learning, or deep reinforcement learning, has been making a splash in news headlines in the last couple of years. This type of neural network is given feedback on its performance. It's reinforced on its performance. For example, being designed to optimize to gain points on video games. Popular recent applications of reinforcement learning include Google DeepMind's networks that exceeded human performance on dozens of Atari video games, and similarly, Google DeepMind in 2016 and then again in 2017 famously defeated the world's best human players at the board game of Go. Go is a complex game that can't be solved formally and requires a lot of quote-unquote intuition, so people thought it would be decades longer before computers were beating the best humans at that, but deep reinforcement learning cracked it. Again, reinforcement learning is obviously really interesting, but it's relatively complex, and so we'll be leaving that to another live lessons as well. Finally, generative adversarial networks, or GANs, are adept at creating complex images sufficiently realistic that you might have thought only a human could create it. In particular, they can blend styles. So you can take a picture of yourself, feed it into a generative adversarial network, and have it be painted in the style of, say, Claude Monet or Pablo Picasso or whoever. Like RNNs and reinforcement learning, we'll be covering GANs in other live lessons. For these live lessons, we'll have our hands full mastering the fundamentals of deep learning in general by focusing on dense and convolutional networks.